Today we're going to look at the forces acting on a car as it's sitting here and as we go for a drive. So let's get going. Sitting in our car and not going anywhere. What kind of forces are acting on us? Well, we've got gravity pushing down on us, actually pulling us towards the center of the earth. That force is acting in a downward direction. Now we're not moving in a downward direction, so there must be an equal and opposite force pointing upwards. That's our normal force supplied by the ground. Okay, let's start moving. When I push on the gas pedal, the car starts going faster and faster, and we call this acceleration. What's happening is the engine is putting a great deal of force on the tires, which essentially pushes the car forward. So we have this huge forward force. There's another force pointing in the other direction, and that's friction caused by the road and the axles and the air resistance. But right now, the force in the forward direction caused by the engine is much greater. So the car continues to accelerate faster and faster. Okay, we're going way too fast, so let's slow down a little bit. I'm going to press on the brakes, which is going to slow down the rotation of the wheels. This is essentially going to give us a greater force in the backward direction. Since the force in the backward direction is greater than the force in the forward direction, we're going to slow down. Okay, I found a nice cruising speed, so let's look at all the forces. I've still got the downward force of gravity, but that's canceled out by the normal force in an upward direction. I've got the forward force caused by the engine turning the wheels on the ground, but then I've got an equal opposite force in the backward direction caused by the friction and the air resistance. At this point, the forward force and the backward force are equal, so the car is not accelerating or decelerating. It's just going at a constant velocity.